Hey everyone, welcome to our video lesson where today we will be teaching you the concept of selection sorting using Dr. Java. So what is it? Well, it's an algorithm, a method that sorts out an array by moving the data in the least amount of time. For example, I have a list of numbers which I want to be arranged so that it could be increasing. So I would follow the selection sorting algorithm so that it would move the values around and arrange it so that I have this as my output, 1, 2, 3, 4, 5. Descending order follows the same rules. The method in which I would create has to follow the selection sorting algorithm so that it would move the values around and produce this output, 5, 4, 3, 2, 1. But what is the algorithm? Well, here it is. The computer will first go through all the elements, and the next step really depends on you. If you want your array to be increasing, it would find the largest value in that array and switch it to whatever value is in the last index. So in our increasing example, the largest number is 5. The number in the last index is 3. So it takes the 5 and the 3 and switches their values so that the 5 is at the end of the list and the 3 is in the second spot. Because the 5 is at the end, we know that we're one step closer to sorting out our array. From counting from 1 to 5, 5 is the last item on the list. And the method would work its way towards the beginning of the list, swapping the values around, and then you would have your increased array, or the order in which that is increasing. Decreasing. The computer will go through all the elements, but this time it would find the smallest value. And after finding the smallest value, it would switch that to whatever number is in the last index. So here's our array, list of numbers again. The smallest number is a 1. The last number on the list is a 3. It takes the 1 and the 3 and switches their spots so that the 1 is at the end of the list and the 3 is in the third spot. Because the 1 is at the end of the list, we again know that we are one step closer to sorting out our array. Because counting backwards from 5 to 1, I know that 1 is at the end of the list. And the process of swapping would continue from the last index towards the beginning until we have our completed decreasing array. But there is one point in which you should understand. It's that the element that was last moved and is the furthest away in the array will not be included during the next pass. We will be teaching you about the next pass and what this point actually means during our video lesson later on. So don't worry.
Remember, C1 and C are the same note. C1 is an octave higher than C, meaning that C1 is 8 notes above C. Here's how it sounds. That's C, and that's C1. So now let's put the selection sort algorithm into code. Just to get this clear and out of the way before we start, a pass means that we have gone through these 3 steps in the algorithm. So when we say the first pass, we mean that it's gone through these 3 steps once. When we say the second pass, it has gone through the steps twice. When we say that it's a third, when you say that it's a third pass, you're saying that it's gone through these steps 3 times, so on and so forth. So the first step is to go through the elements that we need to go through, right? Because we don't want to go through elements that have already been placed at the end of the list. Then we want to find out which element is the smallest or largest. Depends on if you're trying to put them in ascending order or descending order. If you want to put them in ascending order, you want to find the largest element and put it at the end. But if you want to put them in descending order, you want to find the smallest element and put that at the end. And then the final step is to switch the element with the last element in the array that hasn't been moved. So what we're going to do is we're going to put a integer array called list of num. So obviously it has a list of numbers 8, 1, 7, 4, and 6. And you want to put them in ascending order. Again, don't worry about the number of passes. It's just for the method. And this is just calling the class method. So let's start with step 1. So the first step is to go through all the elements that we need to go through. So we're going to have to use a for loop. And the reason is because we don't want to include the numbers at the end of the list that have already been moved, as I mentioned earlier. So that's why we have a integer variable called a length, and it equals to the list of nums dot length subtract 1. Okay. And then a length has to be less than 0 because we know that an array doesn't have an index less than 0, and you'll see why it can't equal to 0 at the end of the program. If I explain it to you now, it's a bit confusing. And then we want to decrease the a length by 1 when we start every iteration. And one thing you should take note of is that we're not actually decreasing the array length. We're just decreasing that figure, that number, just so we're not comparing the values that have already been moved to the end of the list. So we have a nested for loop here. So basically there's another for loop in this for loop. It declares an integer variable called index, and it equals to 1. And the index has to be less than or equal to a length. And again, that's because we don't want the numbers at the end of the list to be compared in as you continue each pass, and you increase the index by 1. And in this statement, it finds out which element is the largest one. So during the first iteration in this for loop, index equals to 1 and the largest value equals to 0. So basically what you're comparing is list of num at 1 when the index is 1, and then list of num when the index is 0. And then it'll see which one is larger, and if the value of the element when the index equals to 1, or the index, is greater than the element in the index largest value will equal to the index. So say if inside the element list of num, that inside the first index the element equals to 6, and then when list of numbers and the element at list of num when the index is 0 is 2. So we obviously know that 6 is greater than 2. So that means that here largest value will equal to index. So right now largest value equals to 0, right? Because that's what we declared it up here. And the index equals to 1. But when this happened, the value of largest value gets overwritten and equals to 1. And then again this for loop will happen. So that's the second step. It'll find the element with the largest value. One thing you can take note of is that if index equals to 0, we can do this, it's not wrong. It's just that you're basically comparing two of the same things. It's kind of useless, right? Okay, so we're going to continue on. So the last step is to compare the last element in the list. Okay, so this is just basically switching the places. So we have an integer variable called temp, and that's going to hold the value of list of num at a length, because at a length it'll be at the end of the list. And then the list of num at a length will be overwritten by list of num largest value, and then list of num at largest value will be overwritten and it'll equal to temp. Okay, so when we compile this and we run it, the original array was 8, 1, 7, 4, and 6. And 8 is the largest, so 8 and 6 change places. And at the end of the first pass, the order would be 6, 1, 7, 4, 8. And then it won't count the 8 here. It'll just look at 6, 1, 7, 4. And it'll see that 7 is the largest number. So 7 and 4 switch. And then it won't count 7 here, 7 and 8 here. It'll see 6, 1, 4, and it'll say that 6 is the largest number. And it'll swap places with 4, and this will continue until the array. So now we're going to look at another example, okay, and we're going to run it. And here in this example, it's just going to show you that sometimes when we rearrange the numbers, the one that's supposed to be at the end of the list will already be at the end of the list. So what I'm trying to say is that in the original array here, it's 5, 1, 3, 9, and 6. So 9 is the largest number, so it switch spots with 6. So then at the end of the first pass, it'll be 5, 1, 3, 6, and 9. So when we start the second pass, 6 will be found the highest number. But since 6 is the largest number, it'll swap places with itself. And then it'll continue on until it has become 1, 3, 5, 6, and 9. Finally, in our last example, it's just going to show you what happens when there are two of the same numbers. And if there are two of the same numbers, the one that comes first will be checked over. So here in this case, let's move on to the second pass. We know that the computer will ignore 6 and 9, and it'll look at 5, 5, and 3. And because 5 is the largest, it'll take 5. But it'll take the 5 at the first index because it comes before the 5 at the second index. And there's also one other thing I need to show you. All we'd have to do is change the sign here to less than. And that'll go in descending order. It'll put the smallest number at the end of the list. Like so.
So let's talk about the pros and cons of selection sorting and why it really is the best. So point 1, it's simple to understand. If you go back to the examples we've used previously in this tutorial, you'll understand that it really is easy to get. It's not the hardest algorithm to understand. I know at first it is, like in the past 17 minutes, I'm sure this whole video lesson has overwhelmed you, but go back and it's really easy to understand. It's all about taking the largest or smallest value and putting it in its correct spot. That's all. Second, it requires less memory, so there are less data movement than insertion sort. Third, it's faster than bubble sorting. So as you've heard, bubble sorting will lag every time you use it. So if you want to sort out an array, use selection sorting, not bubble sorting. There are actually two negative things about selection sorting. One is that it's not really efficient for any sized array. So it all depends on the size. If you have an array that's has 100 elements, okay, selection sorting may not be the best. I mean, it will sort it out, but it will double the time it takes to sort out an array that's a size 5. That's all. Second, it will switch the value to its same spot. So unfortunately, if you have an array has the numbers 1, 2, 3, 4, 5, but the 5 is already in its original and correct spot, this algorithm will actually take that 5 and just place it in its own spot. So that's the only negative thing about it. But selection sorting really is the best. I mean, it's simple and easy to implement and understand. It really is. It requires less memory, there are less data movement, and it's much faster than bubble sorting. Bubble sorting lags, selection sorting doesn't. But this all depends on the size of the array.
You could thank me now. Go ahead. Thank me later, yeah, I know what I said.